this is GCSE Physics. This is Atomic Structure Lesson 7, and the title is Decay Equations. So we've got one objective, and it's simply to solve decay equations. Now what I'm going to do is to put the worksheet on the screen. So here you go. So if you want, you can have a go at these 12 questions. I'm going to, in a second, do the first one as an example. And obviously it's completely up to you. You can either have a go now, or you can wait for the example and then try and continue from there. And I'll show you how you use this table and complete the questions. So I'm going to start the questions now. So pause if you want to obviously do the sheet. So the first one, for example, is show what happens when plutonium-242 decays by alpha emission. So we've got plutonium-242, so that's the mass number, and it decays by alpha emission. So we've got plutonium-242 for the mass, and the atomic number is 94. So that's the total number of protons. And it decays by alpha emission. So it decays by, and I'm going to put the alpha emission in first. So I'm going to put alpha 42. Just so it's really easy to get the numbers. Then I just need to make the left-hand side and the right-hand side equal to each other. So 242 minus 4 is 238. And then 94 minus 2 is 92. So now both sides are equal. 238 plus 4, 242. 92 plus 2 gives us 94. And what we need to do is check the proton number of our daughter nuclide. So that's 92. And then marry that up with what's on the table, so that'll be uranium. Obviously, in an examination, you would not have to know the daughter nuclide. The uranium, you could possibly just put an X. But obviously with the table, that's possible. So that's the example for the first one. So if you want to carry on. Another one, I'll tell you what I'll do next. I'll do question 5 as an example as well. So that's beta emission, and then I'll go through the rest of the questions. So number 5 says, show what happens when hydrogen 3 decays by beta emission. So hydrogen 3 would be hydrogen 3, mass number 3. And hydrogen has an atomic number of 1. So that's the number of protons. And it decays by beta. So if you remember from the lesson previous, lesson 6, we have a plus, so we've got beta. And it's 0 minus 1. And then we just need to make the numbers add up. So something minus 1 on the right hand side to give us 1 would be 2. And something in 0 would obviously be 3. So now both sides are balanced. Then we can check what the atomic number is on the daughter nuclide, which is a 2. So that would be helium. Just rub that out. So that's number 1 and number 5. So if you want to complete the other 10 questions, that's great. And then I'm going to go through all the answers now anyway. So I'm just going to clear this up. And then let's go. So number 2, get rid of that. So number 2 next. So hopefully you've done these now. If not, pause and obviously have a go at them. I'm going to go for the answers. So number 2. So show what happens when uranium-238 decays by alpha emission. So uranium-238. We look at uranium. So it's got 92 protons. And it decays by alpha. So plus alpha, which is 42, the helium nucleus. And then 238 take away 4 is 234. And 92 take away 2 is 90. Then we need to check the proton number. 90 would be thorium, TH. So that's number 2. Okay, let's move on. Let's do number 3. So number 3, show what happens when radium-230 decays by alpha emission. So radium-230, so radium is this one. So it's Ra-230. And the proton number is 88. And it's going to decay by alpha emission. So alpha 42. Then we just need to make them add up. So that would be 226. That's a really bad 8. And 86. So what's got 86 protons? That would be radon, Rn. Okay, so let's look at number 4. So number 4 is show what happens when carbon-15 decays by beta emission. So carbon-15 would be carbon-15. Now carbon has got an atomic number of 6. And it decays by beta emission. So beta, I'm going to put the plus beta 0 minus 1 from last lesson. And then just make them add up. So something add 0 would obviously be 15. Something take away 1 to give 6 would be 7. What's got 7 protons? Or an atomic number of 7, that would be nitrogen. Okay, so we did 5 as an example, so let's look at number 6. Show what happens when oxygen 19 decays by beta emission. So number 6. So oxygen 19, so that'll be oxygen 19. It's got a proton number of 8. It decays by beta emission. So I'm going to put the plus beta in first, so 0 minus 1. Then make them add up. So something plus 0 to get 19 would obviously be 19. And something take away 1 to give 8 is 9. So what's got 9 protons? That'll be fluorine. So that'll be F. Okay, hopefully that's okay. Let's make some room. Should probably pause the video next time I do this, but never mind. Right, next one. So that's number 6. We've done so on to number 7. So it show how protactinium 234 can be formed by alpha emission. So that'll be some unknown element decaying into protactinium 234 via alpha emission. So number 7. So making protactinium. So protactinium is Pa 91. So it's Pa. It's got 91 protons and a mass number of 234. Plus, and it was formed by alpha emission. So alpha 42. Then we need to work backwards. So 234 plus 4 is 238. And 91 plus 3 is 93. So it's got 93 protons. Neptunium, Np. So it should look like that. Okay, next one. We get a bit of room. Number 8. So show how gold can be formed by alpha emission. So once again, so we've got gold. So gold is Au, so that's 79 protons. So Au, 79 for the atomic number, and 210. And it's formed by alpha emission. It's got plus alpha. Then we just need to work backwards. So 210 plus 4 is 214. 79 plus 2 is 81. And what's got 81 protons? Thallium, Tl. Okay, number 9. So number 9 says, show how uranium-237 can be formed by alpha emission. So we've got uranium-237. So the proton number for uranium is 92. It's formed by alpha emission, so we've got plus alpha 42. Then we just need to add them up. So 237 plus 4 is 241. 92 plus 2, 94. So what's got 94 protons? Plutonium. Pu. Pu. So that's number 9. Okay, we've got 3 more left. I'm going to make some room. So number 10. Just put it down here with a bit of room. Show how lithium-6 can be formed by beta emission. So we've got lithium-6 being formed. So lithium, so that's up here. So lithium-6, and it's got 3 protons. And it's formed by beta emission, so I need to put beta 0 minus 1, and then just work backwards, add them up. So 6 plus 0 is 6. 3 minus 1 is 2. So 2 protons is helium, so some really strange, very heavy helium. So He, that's the answer to number 10. Okay, let's do number 11. So show what happens when lead decays by alpha emission. So lead decaying, so lead is, there we go, 82. And Pb, so Pb, 218, 82. Decays by alpha emission, so we've got plus 42, so we're back to the ones that we were doing at the beginning. So something plus 4 to give 218, so that's 214, and then something plus 2 to give 82 is 80. So what's got 80 protons? That'll be mercury, Hg. So hopefully that one went okay. Then we've got one more left, number 12, just make some more room. Okay, so number 12. So it says, show what happens when lithium-9 decays by beta emission. So lithium is there, so lithium-9. Lithium's got a proton number of 3, decays by beta emission, so plus beta 0 minus 1, then just make both sides add up. So something in 0 to make 9 is 9. Something take away 1 to make 3 is 4. So it's got 4 protons. That will be beryllium. Hopefully that went okay. If you got all 12 straight away, that's absolutely fantastic. Well done. If you watched the first couple of examples and then did the rest, that's also brilliant. If you kind of got this into the swing of things and you know, understanding and getting the hang of the types of questions towards the end, that's also really good. If you need any more practice, you can obviously rewind and do the entire thing again and then check your answers once more. So I hope you found that helpful, and thanks for watching, and I'll speak to you soon.